Hello and warm welcome to our session on modernizing Mercedes-Benz global ordering system with Rocket on AWS and also using GenAI. My name is Manuel Breitfeld. I'm heading the delivery for Mercedes-Benz Germany at Capgemini, and I'm very excited to be standing here today with Christian.
Thanks, Manuel, and warm welcome also from my side. I'm Christian Klemme from Mercedes-Benz IT, based in Stuttgart, Germany, and happy to be here with Manuel to make you familiar with our big project, which we call Go to Cloud, because it's about the application global ordering, in short, Go, that together with Capgemini and more partners, we move to the cloud from the mainframe. And I'll actually start by making you familiar a little bit with the dimensions of this application. On the left-hand side of this slide, you can see the process that is supported by this application. It's, if you want, the lifeline of our sales operations at Mercedes-Benz. And we always visualize this by using the letter Y, because it's the processes that are behind. Yeah? If you look from the right-hand side, there's all master data creation. So this is how we set up more or less our product portfolio inside global ordering. And this is where the orders come in based on that master data. From the left-hand side, you can see what we call volume planning or sales planning. This is where we more or less determine how many cars we want to sell in which market, which type of cars we want to sell in which period. And then all this data comes together in global ordering, and based on this we do the ordering, and we also serve production with the orders. So you can imagine, and that is stated on the bottom of this picture, each and every car that we sell, that we produce, goes through this system landscape. And this is why I actually said this is where the heartbeat of the company goes. And to give you some numbers, only selected ones, I'm not going to read you through the entire slides. We talk about an application that has more than 20,000 interfaces in all parts of our company. If you look at the size of the application in terms of lines of code, we talk about 5 million lines of code in Java and Go, and more or less the same size in the other language. We have a huge workload, at least for our dimensions. So around about 50% of the mainframe workload is with global ordering. And technically spoken, we support more than 800 queues. We support more than 5.1 billion messages per year. And we have 450 batches running on the mainframe application. And by this, we support more than 8,000 users in 150 countries. So it's quite impressive, and for us it's super important. And this is why we decided not to refactor the application, but to go in more steps to start with a replatforming. And this is what we want to present today. So how did we tackle this program or this project of replatforming this important application for Mercedes-Benz? You can see the steps right here, and we started already more than 2 years ago. Once having the idea, then going through the rapid assessment together with the provider Rocket Software, who provides this assessment as a standard service for all applications, for all workloads that are supposed to move from the mainframe to the cloud. Having this assessment done, we then looked at the results and initiated the mitigating measures for the trouble or for the issues that we found. And of course, we had to calculate the business case, which at the beginning already showed us significant cost savings compared to what we have as cost on the mainframe today. And this is more or less also how we initiated the entire mainframe exit program that is running now at Mercedes-Benz. So the entire company is about to leave this platform in the next couple of years. How did we tackle it from a team perspective? So in the end, we decided for Capgemini to be our general contractor. So as you can imagine, and as we will show later, there's a whole team and a whole whole number of partners that are acting together here to make this happen. But we chose for Capgemini to be our general contractor who manages for us the relationship between the other partners, namely AWS, of course, as the provider of the cloud platform, but also Rocket as being the one serving us with what they call the enterprise server, so the emulation for mainframe workloads on the cloud. And of course, we as the MB customers, we also are part of the game together, IT and business, which is also one of the key success factors. So then in 2025, we finally got to go to start the project. We have strong management involvement, of course, which is important, top management involvement. We also applied GenAI in first some POC pilot setups, but later then also for larger workloads. And Manuel will be speaking about that a little bit more in detail in a minute. And also from our perspective, a clear factor for success is that we go in stages. We start with parts of the application. In this case, we even start with a stateless part of, with some stateless services, which are part of the application to make sure that we can really run this in parallel on the old platform and the new platform in parallel to be sure that the new implementation on the cloud then also serves to the same levels of service levels as the old application. And for 2026, we have still a way to go. So we will then migrate the full size application. We'll have to cancel all our legacy contracts, also make sure that the business case really is implemented and realized and the savings really come. And of course, set up the future mode of operations on the new platform with the new partners. And finally, fully dismantle the mainframe, which is super important in terms of getting really rid of the cost. Another key success factor is what we call the global ordering facade. And what do we mean with the facade? That's also based on a standard product that we buy from MuleSoft. It's a gateway which allows you to direct the workload that comes from our web clients to either the cloud backend or the mainframe backend, which is, of course, a very handy feature in terms of testing, but also allows you very quick way back in terms of trouble. And of course, that's the most important part, prevents all your consumers from doing huge changes when interacting with you. They simply have to call another URL, but will not be impacted by what we do in the background when migrating the application. So this is how we believe we can migrate this huge application with the highest speed at the lowest risk. Also fully integrated in the existing Mercedes-Benz landscape, being then ready for the future from a technology perspective, but still having all options open in terms of modernizing the application then towards a more modern and cloud-native infrastructure. One more thing that is important in our project is the platform that we move to. It's not an AWS native landing zone that we're going at. We have mentioned Rocket as one of the software providers many times now. Rocket Software is, and their product, the enterprise server, is more or less the landing zone that we need to emulate the mainframe on the cloud. And this landing zone is fully managed by AWS. So not something that we have to manage from Mercedes-Benz or Capgemini side, but we just buy this as a service from AWS. But more than that, Rocket is only the mainframe part. We also have a Java stack on the cloud. We have some services for batch processing, but also, of course, for database services. Messaging is an important part. And then all the things that you need on top, of course, like monitoring, like financials and so on, and the storage part is all combined in this landing zone, what we call, or this platform, which we call the Helios platform. It's a Mercedes-Benz internal product that combines some of IAM services that we need on top, of course, with the standard services that you find on that landscape that I have just shown. So that's about all, but most important, not to mention last but not least, is the partnership that we have set up to make this program successful. Starting, of course, with us as the customer, who are the ones who want to realize this project, but moreover then the general contract that we have with Capgemini, supported by the two main partners, AWS as the cloud platform provider and Rocket as being the inventor of the enterprise server, the emulation of the cloud, of the mainframe in the cloud. And with this, I'm happy to hand over to Manuel, who will make you familiar a little bit with the GenAI part of the story, which is, of course, the most exciting one. So go ahead, Manuel.
Thank you, Chris. Thank you, Christian. Before we come to the GenAI topic, maybe let me walk you backwards a little bit. If you're familiar with the topic of legacy modernization, you might know those phases. So typically, when we go into mainframe modernization, we look into 4 phases, and with those 4 phases, we try to find the best solution for that specific problem. So typically you want to start with the assess phase, where you look into the whole landscape. And now with Mercedes-Benz for global ordering, we've also done that, but also Capgemini is doing that application for over 25 years. So we kind of knew already what's at stake. We kind of knew the application. We kind of knew how it's integrated into the landscape. Christian said it's about huge interfaces that we have to deal with. So we knew that. If we don't know it, we help ourselves with tools. Cap 360 is one of them. Brad is another one that is also using AI to determine how do the application structure, how does it look like, and how do interfaces look like. So as soon as this is clear, and as soon also the client is clear on what the strategy is, Christian mentioned for global ordering, we've chosen the replatforming or rehosting. Some call it replatform, some call it rehosting. So basically kind of a emulation on the mainframe with Rocket. As soon as you have that, you decide, okay, this is our strategy. You see the familiar 6 R's, some have 5, some have 7. Here it's 6. Basically, what is your migration strategy? For global ordering, we've chosen to go with a replatforming approach. We wanted to keep the application as untouched as possible, and also be sure that kind of the interfaces, we have a good way to deal with that. But also, and this is where I'm coming in with regards to AI, at the very beginning, we already knew there might be some cases where we want to go refactor, because at the same time, Mercedes-Benz is doing their sales operation is refactoring parts of that already. So it does make sense from a business case perspective to look into global ordering at once, but also see if there are some slices that would make sense to refactor them. So that was the idea. And when we went into the migrate and modernize part, we actually identified the parts where we felt like those would be good elements to refactor. Gen Revive is mentioned in the bottom. I come to that shortly. And obviously, not to forget, operate and optimize. We are not at that stage yet, but we're just starting to have first services available where we learn how to operate and how to optimize them, but definitely a big part of the story. If we look into the AI and GenAI effects of that phases, those are the elements that we at Capgemini use. So for the assessment, I've mentioned that earlier, we use a couple of tools that help us identify what is the inventory, how is the code look like, and also what is business cases, what are business rules that are being included in the application. This is where we use Brad Cap 360 or also Gen Insights, tools that just help us to get a bit of an idea on the application. The other part is agentic AI refactoring. And I mean, if you listen some of the sessions today and probably also coming this week, that's a big story. It's also a big story here. So with Gen Revive, which I will come to later in the talk, we have a multi-agent setup based on agentic AI that does transform legacy code into the new world. Obviously, we also use coding assistance, so all developers, and we've heard it in the keynote as well, like all developers happy to use some assistance while coding. This is also true here. And then when it comes to testing, we also have tools that help us identify, was that test successful, or is there an error in the testing? But as I said, I want to come to Gen Revive, and this is what we have been implementing in the last, basically this year, within global ordering. And the headline states kind of the key message. We don't just use AI, we want to combine it with our expertise and our strength. So on the left-hand side of the picture, you see this is what our team currently still does. And where I believe it's fully essential that they do it. So it's about having an analysis of the application, knowing what do I actually want to refactor. I need to know it. Also providing documents. What are the documents that are helpful for the AI to be able to transform the code? Right? It's not only the code, it's also documentation that exists, it's test cases that might exist. So all the things that you have that do help the AI to better transform, that's helpful and you need to provide it. And obviously you need to specify what to do. Like in this case, we want to migrate from COBOL to Java. So I need to learn, I need to train the AI how it's done. And to be able to do so, in Gen Revive, we call it cookbooks. I need to explain, I need to see like, look, this is how you would typically transform that module into that part in Java to give the AI kind of a feeling on what's right and what's wrong. And Gen Revive then in turn has, it's similar like a software engineering team. You have the agent being the software engineer, you have the agent being the software reviewer, you have the tester, you have the DevOps engineer, and actually you really have roles. You assign to the AI, look, you are the agent, you are the engineer, and that agent does software engineering. It doesn't do testing because there's a different role for that. So what they do, they kind of build a software engineering team that is then orchestrated by a human. And this is kind of the basis. And while it might look theory on paper, it's actually already on production and has been able to transform quite a number of code for Mercedes-Benz. Now looking into that specific case, so I called it within Go to Cloud and within the application at Mercedes-Benz, there is one service called pricing service, consisting of 1.3 million lines of code, 1.3 million lines of COBOL code. And what you see in that on that slide, it's kind of the rough architecture. It's running on the mainframe. It is split between a Java part, which is running on IBM WebSphere, and COBOL part, which is on IBM Kix. Both parts accessing the same database and Java calling COBOL as well. This is what we have today. And what we've decided is we want to migrate the COBOL part into Java and have just one application after that. So the outcome, you see it on the right-hand side, is Christian mentioned the Go Facade. this is kind of the layer sitting on top. This is where all calls go in. This is where we can check, is it a successful test case or is it unsuccessful? This is where we can also route certain calls. So should that call already go on the new Java part or should it stay on the mainframe? This is kind of the tooling that allows us to do testing, that allows us also to control the go live. And also what Christian mentioned earlier is it allows us to minimize changes with all neighboring systems. They should not do a lot of changes. In fact, they only change the URL. And then in yellow, you see the new Java stack. So everything which is on the two boxes on the left-hand side, we have the COBOL part, we have the Java part. Everything is now moved into Java with Generative. And there is still one problem. Like the COBOL part and the Java part, they have been accessing the same database. And it's a pricing service, but in fact, it's also part of the whole global ordering system. So the data in that specific case is still existing on the mainframe. So what we've used is Precisely as a tool. Precisely is able to basically sync data, lots of data, basically in real time. So what we're doing is to be able to have that data accessible on the new service, we use Precisely to always sync that data in real time. And with that, we not only have like that new service modern in your new target language, we have been able to reduce mainframe costs at the same time and have also been able to actually increase the speed for the neighboring systems. So that's the core concept, and I've talked a bit on the story already, but I just also want to walk you through that again. I feel like nowadays with people talk about Gen AI, I think it's always better if you show how it actually went. And it all started with a problem. I think beginning of the year, that pricing service that was on the mainframe was not capable of executing as many calls as Mercedes-Benz would need for modernizing parts of their new system. So the problem was what to do. Should we up the mainframe infrastructure and try to just make it bigger to be able to handle those calls? Or the other solution was try GenAI. And in fact, it was kind of trying GenAI, not fully knowing if it would succeed. So that was beginning of February, where we've decided, okay, let's try that, knowing that the number of lines of code with the 1.3 million is quite a challenge. But in March, if we look back, there was actually already the first commit into the GitHub repository, and not too much later, in May, we had the first version which was deployable. So really in a very, very short time, we were able to transform the 1.3 million lines of code into a Java application. And just recently, because so many people are asking, now, how does that code look like? Are you able to maintain it? Just recently, we've looked into the code, and you're not able to distinguish, is that code written by a human, or is it the AI that has written that? Also, to be frank, there are some parts, and you see it in the additional performance tuning, there are some parts that we did adjust manually. So especially coming from legacy, coming from the mainframe, where in this case, the database access is just very, very, very quick, and everything is in memory. Obviously, that's not the case on AWS, and it shouldn't be like that. So there are parts that you need to tune, and that the AI in this stage does not know that it should be tuned. So what we did is we looked into all the database successes, and this is where we've done some fine tuning to be able to max out the speed that we needed to do. Also, all the infra setup, mainframe now is running on AWS, and the precisely data sync also fully functional then in September. And not long ago, I think almost 1 month, 1.5 months back, there was a big go live for Mercedes-Benz of that whole system. The pricing service is a part of that, and went live successfully. Actually, is faster than before with that Gen-Revive use case. Now, having that in mind and also having that success story checked, we are currently evaluating together with Mercedes-Benz what are other parts where we feel like we will find a similar success story. Where are parts where we feel like, okay, we don't want to just refactor, we don't want to just rehost, we want to refactor, and we want to use the benefits of GenAI. So summing that story up, it's 1.3 million lines of COBOL code. It's also 500 megabytes of database records that are kept in sync in real time. So it's really a big achievement. Now, one last thing that I want to come to is the facade or integration layer that we also call it is now in production and was really a key element to be able to test the whole service, but also to be able to bring it live. So while we did the QA phase, the testing phase, the UAT phase, we were always able to use the integration layer and route calls to mainframe, but also route calls to Java. And because precisely was still taking care of the database, so it was really clear, like from both worlds, you should get the exact same result. So this is what we've did in testing. We've monitored all calls, and we've actually looked into the integration layer, and it was a simple check. Like the result that you get from both systems should be the same, right? And this reduced the testing effort enormously, because it was not only able to check it manually, we were also able to test with real data. It was not like someone who needed to sit and test certain systems. We were able to use and capture real data and just run it. Just run it against the two systems, and then be able to go into production with a good check. And it turned out well also in production. As soon as we went live, we were also able to test both of the systems, and were able to compare all of those results. Moreover, it's not only a functionality that we use and that I think you should use in the system to compare results. It's also something where you can monitor what is your latency, what is your throughput, how is speed looking, are you achieving against SLAs or not? Like all those NFRs that you certainly have in your applications, you can also check that if you have something like an integration layer, something like a facade. And what is written on the right in the outcomes section, controlled cutover, we've said that already. Like you can control the systems, when should they change, and then it's your decision to turn over. It's not their decision, you can control it. You have your automated quality assurance because you are actually doing all the tests with the facade. And in this specific case, obviously all of us very proud, we actually didn't have any incident on go live for such a big system, which again was migrated with AI. And lastly, on that screenshot, yeah, it's the colors are visible here too. You see what the result is. Yellow is the mainframe system that was running before the pricing service on the mainframe system in COBOL. Green is the one in Java, and you see it has been running in parallel for quite a while. That's just the testing that I've said, and then at a certain point in time, we were able to just cut it off, as we've seen it. The performance is just better all the way, and even spikes. You can handle much better on AWS, obviously, than you would be able to handle it on a mainframe system. Yeah, and with that, we are done with the presentation for today. We would be very happy to answer a couple of questions if you have them. We stand right by, and happy you listened here, and see you then. Thank you very much.